This is some preliminary information for the course project in Chemical Engineering 263. So if you go to APMonitor.com/CHE263, you'll come to the course website and then come down on the right hand side to Python, and you'll see the Python information there on instruction material. The first project is going to be in Python. If you go back up to course information and select projects, and then scroll down to this heat exchanger design problem. If you click that first link, that's just going to be the shell and tube heat exchanger design. So we're going to work through this problem for the project, and so it's kind of a big project, a lot of things going on here in the assignment. And so if we come back to there's also some thermophysical property information in Excel. But what we're going to work on today is just this preliminary assignment right here that's going to help us walk through and just get familiar with this project. Okay, so first of all, organize into groups of 3, decide on a team name, just review some of the heat exchanger items below, and then what I want you to do is then develop some high-level pseudocode. So just list the major steps after reading over this heat exchanger problem here. Just the major steps. You don't have to write code, just in English, write down input, units of measure, input temperatures, etc. Okay, so just kind of map out your code. What we're going to work on right here is just a program that inputs a temperature and records the time, and then we will compute the average, max, and min values. So I'm going to go over to OneNote for this, just so I can write on it. Okay, so here is the problem description. We'll write this program that continually loops, asking the user for additional temperature values with units of measure in degrees Fahrenheit, degrees Celsius, Kelvin, or Rankine. Okay, so a lot of you haven't heard of Rankine before, but it's just 0 Rankine equals 0 Kelvin. Okay, so it's like the absolute value of temperature. Analogous to the difference between Fahrenheit and Kelvin. So the absolute is going to be the absolute is going to be Rankine for Fahrenheit, and the absolute is going to be Kelvin for the Celsius scale. Okay, so we can have any of those 4 units of measure, and then end the loop when the user inputs a blank or non-numeric value. And then we'll also plot the temperature values versus the time that they were entered. Okay, so we want to start from 0 seconds, and then we're going to report the mean, the max, and the min temperatures. And then all the temperatures should be reported in Kelvin regardless of how they were input originally. Okay, so here's some sample input. Here, when you run the program, this might be what it asks. It's going to ask what are the units of measure. Gives you a couple different options. The user inputs Fahrenheit, and then it gives some instructions to input some data. Okay, so we'll input temperatures, and the user is going to input the different temperatures. At each time, it will record the time that they were entered, and then it is going to create a plot. Okay, so it started with 0 seconds, and then 4 seconds later, I entered the second value. About 7 seconds I entered the third value, and so on. So I just entered in those values, and it plotted these in Kelvin. So I input these in Fahrenheit, and then it converted these values to values of Kelvin in the plot. Okay, and then it also did some statistics and just said that we were in max, min, and average values for the temperatures. Okay, so this would be a program, like let's say you had this program running throughout the day and you were just looking at the temperature outside, and let's say this were in hours, and maybe we just went up to 24 hours. We would see an increase in the temperature during the day, and then it cools off at night, and this would just be recording the temperatures, and then when it ends it generates this plot, for example. Okay, so let's go, and I'm just going to keep this open kind of over to the left here. Okay, so just keep that open just so we can see what we're working towards. And then what I'm going to do is just open up IDLE. This is the Python program I'll use. You could also use IPython. This is Python GUI. Okay, and then I'll just put that over here in the on the left-hand side. Okay, and just make it a little bit bigger there. Okay, and now I'm going to create a new file. So this is going to be my Python program, and I'll just bring this over here to the left. Okay, and just rearrange this a little bit. Okay, so there I have my my program. I'm going to go ahead and save it. Let me go ahead and save it to my desktop, and I'll just call this program. Okay, so I have my program. The first thing I need to do is input some units of measure. So I'll just ask for the units, and I'll use raw input and input units, and I'll say that we can either do Fahrenheit, ranking, or Celsius, or Kelvin. Okay, and that will prompt the user for an input. Let me just go and print the units, and if I do that and run it, let's say I put in Tim. Okay, it's just it has no validation of the input. I asked for one of those four, but I'm just going to print what I had received. Okay, in IPython, you may have to use the input instead. Okay, I'm going to use the raw input here. Okay, then the next thing we need to do is validate the input. And so I want to just see if it's equal to F, R, C, or K. And so I'll just convert it first of all to uppercase, just so in case they put in something in lowercase, it's just going to convert it, the units, whatever that string was, to uppercase. And then I'm going to have an if statement here, and if not, units equals to Fahrenheit, or units equals to ranking, or units equals to Celsius, or units equals to Kelvin. Okay, there are more efficient ways of writing this, but just for ease of understanding, I'll write it this way. So if it's any of those, then I'm going to say that I'm going to print invalid units. Okay, so and then let's go ahead and print those out as well. I'll just put the units there, and also say terminating program. Okay, and then the next thing I need to do is I want to do an exit, but first of all, in order to use that, I need to import sys. That's some system commands, and I will exit my program. Okay, so what I've done here is I've just input the units, and then I converted them to uppercase, and then just validated them. And so if they're not the correct units, then it's going to go ahead and exit the program. Let me just go ahead and run it and test this one. So I'll input Tim, invalid units Tim. You can see how it converted it to all uppercases. It says terminating program. Okay, so let me go ahead and run it again with some correct units, and I'll do lowercase r, and it didn't have any message that it had terminated, so it just completed successfully. Okay, so the next thing we need to do is, let's see, we will input some new, let's go ahead and input some new temperatures now. Okay, so we will, let's go ahead and print a message, enter temperatures, blank when done. Okay, so they can enter the temperatures and then just blank or some other non-numeric value when they're done. And so what we'll need to do is just have a while loop here. So while, and then I'll just put true. So it's just going to continually loop until I hit a break command. And then just like I had my units here input as raw input, then let me go ahead and try that here as well. So I'll put my temperature is raw input, and input temperature in, let me remind them what the units are, okay, in units, okay, then plus, and I'll just do a semicolon there just so it makes it look a little bit nicer. Okay, and so I have my temperature. Let's see, I also want to record the time that happened. I don't want to use the new time. I'll do that, and then I also want to import the time package. Okay, so I had system, let me import time, and I'll just get the new clock value, whatever the wall clock is. This is not processing time, this is going to be the clock time. Okay, so I'll just get a new time, record the time and the temperature that was input, and those will be the two things I need to plot later. But I need to now store those. I need to store those values, and I also need to validate the temperature, or this is going to be an infinite loop. So one way to do that is to try to convert the temperature to a floating point number. Okay, so here is a temperature that I've converted to a floating point number. If it's like an x value or something like that, if I type float of x, then it's going to give me an error. But if I do try, and then I do float x and accept. Okay, let's see if I can do accept here. I'm having a hard time doing that through the command prompt. Okay, okay, I think I just need to do this in my script. Apparently the indenting isn't working out here. But I'll just do a try, and I'll put here, I'll put print conversion successful to float. Okay, so just to let us know that it's successful, and if that didn't work, then I'll have an accept, and then I'll break from this loop. Okay, so the first time that I put something in that is not a number, then it's going to then break from this loop. Okay, so I'll print not a number. Okay, and this is I'll go ahead and print temp. Okay, there we go, and then break. Okay, so let's just go ahead and run this one as well. Okay, so I'm going to put in my units. First of all, I'll put in Celsius, 230. So it said conversion successful to float. Let me put in X. Okay, so not a number, and then it did a break from that loop and then terminated the program. Okay, so I'm going to just take away these print statements. That was just to see how this worked. But basically, you can put anything that you want to try in this area. If there's any error, then it's going to revert over to this section of code. Okay, so that allows us to break out of this infinite while loop. Okay, so I have my values. I'm going to be recording the times. I'm going to be recording the new temperatures. So let me now convert those temperatures over to Kelvin. Okay, so now that I've validated that input, I know it's a floating point number. I'm going to need to, okay, so let me validate temperature input. I'll put a couple lines of code and ask for new temperature. Okay, and then the next one that I'll do is convert the units to Kelvin. Okay, so I need to check and see if, I'll make this just a little bit bigger here. So if it's not Kelvin, then I need to convert it. So I have to put the double equal sign for comparison. I'm comparing units to C. And if it is equal to C, then I'll just say my temperature equals temperature plus 273.15. Okay, that converts it to Kelvin. And then else if it's ELIF, units equals to, and I'll do Fahrenheit next. Okay, so this one is just a little bit trickier. I just have to do minus 32 times 5 divided by 9, and then add 273.15. Okay, so that converts if my input is in Fahrenheit, and it's going to convert it to Kelvin. And let me do one more for ranking. Okay, so this one's very similar to Fahrenheit, but it's on the absolute scale. And I'll just copy this over. I just don't add the 273.15. Okay, so I have my conversion there between Celsius, Fahrenheit ranking to Kelvin. So now temp is in Kelvin. And I also have the new time. So now I want to plot those, but I need to store those first as I go through this loop so that I can plot them later. Okay, so let me just import NumPy as NP. Just shorten the name to NP, and let's. Okay, so I'm going to store the values. Okay, but I don't know how many values are going to be input, so I can't necessarily create a blank array up here. So what I'll do is, or I can't create an array with a certain number of elements. I'm just going to create a blank array. So I'm going to store the time, and I'll just do np array and just give it a blank empty array. And then I'll store the temperature as well, and I'll do an array that is blank and empty. Okay, so I'm just going to create those, and then what I'm going to do down here is I'm going to append to, every time I go through this loop, I'll just go and append another number to that. So my new s time is going to be np append. So I'm going to use numpy append function, and I'm going to take my s time, whatever it was, and then add on to it the new time. Okay, and then I'm also going to do the same thing for my temperature, s temp, and then my new temperature. So it's just going to add a new element to that array. It's going to add them together, and then s temp is going to be this new combined array. So it's just going to grow the array as I go throughout this loop. Okay, so I've appended that. I think I'm ready to plot these values now as I go through it. Let's just see if I have the right kind of inputs. Okay, invalid syntax. Oh, you know what? I did those before. That should have been after. Okay, just get rid of those. You only need the colon after the statement. Okay, save that again, run it. Okay, so I'm going to input, let's say I have them in ranking. Okay, so 450, 540, 320, and then I will enter, and it's going to be done. But let me go ahead and print s time. Okay, so those are the started basically at 0 time when the clock started, then 2 seconds later, and then 4 seconds later I input the third value. Okay, and then I have print and then s temp. So those are the temperatures in Kelvin. So converted them to Kelvin from ranking, and then we want to plot those values. Okay, so let's go down here. I'm just going to import, just kind of good practice to import all your packages that you need up top. Okay, so I'm going to import matplotlib pyplot as plt, and then down below I will let's go ahead and just create a new plot, and I'm just going to plot s time versus s temp. I'm going to make those red circles. Okay, and then I'm going to show that. Okay, so I'll just show those values. Now again, if you're in IPython, here are some instructions for plotting. If you're in IPython instead, just come down to the Python generate plots, and okay, if using the IPython notebook, exclude the plt show and include matplotlib inline before loading the matplotlib pyplot. Okay, so just some examples there of how to do it in IPython versus ideally just in the text version that you can run through the command line. Okay, so we are at the command line right now. We're not doing the IPython, so we're going to do the plt show. Okay, so let's run this one more time, and then we'll also need to do our statistics as the last thing. Okay, so we're going to run it. Let's say we're in Fahrenheit, and let's say it started off at freezing temperature today. It warmed up a couple hours later to 36, and then let's say 42, 50. I got really warm that day, and then started cooling off again. Okay, 35, and then got down to 32. And maybe went just a little bit below freezing for the day. Okay, so these are the temperatures for the day, and then let's bring up our plot. Okay, so it brought up a plot here of our temperatures. These are the seconds from when I first entered a temperature, how many seconds after. You can see I got a little bit faster entering temperatures, but it was about 21 seconds into it that I entered my last temperature. Okay, so there is my data. Let me clean up the plot just a little bit, make it look a little bit better, add some X labels and Y labels to it. Okay, so X label, let's say I say that's time in seconds, and then I'll also add a Y label, and that is the temperature in Kelvin. Okay, okay, and then let's see, let me do the statistics as well. We forgot to do our statistics. So our statistics are going to be the max, min, and mean value. Okay, so I'll just go ahead and print max, and then we need to convert this to a string, our number, and I'll just do numpy max of s temp. Okay, so that's going to compute our max value right here. I'm going to convert it to a string and then put it together with our indicating that it's the maximum value. Let me copy this twice, and I'll do min and then average, and then just change this to min and then mean. Okay, so we've printed out some statistics on our temperatures as well. So let's run this just one more time. I also want to show you how to export the plot so you can include it in something like a Word document or a report. So let's do our, we'll do it in Celsius now for SI units. Okay, so we're going to input the temperature. Let's say we started off at 0 degrees that day, started warming up, then went to a very nice 30 degrees for that day. Took a little while, but it started cooling down. I'll just wait just a bit to enter the 22, and then 18, 16. Okay, so I'm going to enter them faster now. So I'm recording them faster. 9, 7, 3, 2. Okay, so that was our ending temperature for the day, and then it's going to input a plot. Okay, so you can see I had kind of sparse, a little bit slow throughout the day. There's our 22 right there, and then I input some temperatures pretty fast. Okay, so so I also want to show you how to export this as well. So you can kind of resize it right here, and then you can click this save button, and then if you go to the desktop, you can save it as different formats. EPS is very good if you're going to be putting it into a LaTeX document. PNG is good if you're going to be putting it into like a PowerPoint document. If you're going to be putting it into Word, I guess PNG would probably be the best option for that here as well. Okay, so PNG is probably your best bet. I'll just save that as figure 1, and it's going to clean it up a little bit. It's going to get rid of some of this gray area here. You can also just use the snipping tool in Windows. I don't like this very much because then it keeps the gray there, but you can essentially just grab it just like that, and then copy it, save it, things like that. Okay, I'll save that to the desktop too. Okay, and then you can see after I closed my plot, then it did the statistics. One of the things with Python is when you open up a plot, it's going to hold the execution of the code until you close the plot, and then it'll continue executing. If you want to put these before it opens the plot or shows the plot, then it will compute those before it prints the graph. Okay, and then I just come back to my, so here's the one that I did through the snipping tool. I'll just go ahead and open this. Okay, so you can see that's okay. But if you had exported it instead, it's going to look much nicer with a white background, and just a little bit nicer than just snipping it. Okay, so this program, I'll go ahead and post the source code to this project area. Okay, under the projects, it's kind of a warm-up project for the heat exchanger one, but I'll post this video and the source code under this project help resources here on the right under the projects link. Okay, well, thanks for watching, and I'll also have some additional videos to help you with the project.